In this example, we've been given the function y equals 4x plus 1 all raised to the exponent of 2x plus 3. You will note that this is not an algebraic function. To be an algebraic function, the exponent must be constant, and the exponent in this case is 2x plus 3. Neither is it an exponential function. To be an exponential function, the base must be a constant, and the base in this case is a 4x plus 1. So we have to take a rather unique approach to find the derivative of this particular function. What we're going to start by doing is logging both sides of the equation, and we will use logs of base e, so natural logs. So that's what you see in the second line of our solution. The next thing we've done is we've used one of our laws of logs so that we end up with our third line, which is the natural log of y equals 2x plus 3 all multiplied by the natural log of 4x plus 1. In this form, we are going to differentiate both sides of the equation with respect to x. This means we must use implicit differentiation. If I was taking the derivative of the natural log of x with respect to x, then its derivative would be 1 divided by x. But on the left-hand side of the equation, I have the natural log of y. So when I take its derivative with respect to x, I end up getting 1 divided by y prime. On the right-hand side of the equation, the variables I'm dealing with are x's. Therefore, differentiating them with respect to x should not be a huge difficulty. However, I am going to have to use the product rule because I have a linear function, 2x plus 3, being multiplied by the logarithmic function, the natural log of 4x plus 1. So I am going to be using the product rule here, where f of x will be the 2x plus 3, and g of x will be the natural log of 4x plus 1. So I start using the product rule. I have f of x, which is 2x plus 3, being multiplied by g prime of x. Well, when I take the derivative of the natural log of 4x plus 1, I have to use the chain rule, and its derivative is 1 divided by 4x plus 1, and that's all multiplied by 4. Then I add to that my g of x, the natural log of 4x plus 1, and I multiply it by f prime of x, which in this case is 2. In the next line, I've just cleaned it up a little bit, so I have 1 divided by y prime equals 4 times 2x plus 3, all divided by 4x plus 1, and we add to that 2 natural log of 4x plus 1. Remember that I am trying to solve for y prime. So to do so, I must multiply both sides of the equation by y. And I end up with y prime equaling, in the squared brackets, 4 times 2x plus 3, all divided by 4x plus 1. Add to that 2 natural log of 4x plus 1. And then that is all multiplied by y. If you remember, y from our very first step, or the function that was provided, y is equal to 4x plus 1 raised to the 2x plus 3. So now I can substitute this back in, and I can get my final derivative, y prime, expressed solely in terms of x, so I end up with y prime equaling 4 times 2x plus 3 divided by 4x plus 1. Add to that 2 natural log of 4x plus 1, and that whole thing is multiplied by 4x plus 1 raised to the 2x plus 3.